Hello. Yeah, so those are, thank you very much. Those are my contact information if you want to ask questions later also, or just get in touch, feel free. It's my email, my Mastodon, and my Twitter. So, hi. I should do some advertising. We have a Tor booth in Building K where all the projects are. There are stickers, so feel free to go and grab. And we have a relay operator meetup if you want to run a relay. That's tomorrow, 3 p.m. Building H, room 3244. So note that down if you want to come. It's 1 hour and you can ask questions and know how you can run a relay and what do you need. So my name is Sylvia. Online, I'm a hero. I work at the Tor project and I also part of the information security group at UPC Barcelona. So what this talk is about, it's not a general talk about Tor, but I will go through what Tor is and what does it do so that we have that information fresh. There is a Tor talk tomorrow in the privacy track by Roger. It's at 11. The room is Jason, I think, or Johnson, not Jason. Yeah, so and then we will talk about onion services. Again, I will go quickly through how onion service work and the architecture because the main topic is how can I use onion services. So what is Tor actually? So Tor is free software to begin with. It's a community of people that do different things. We have developers, researchers, relay operators, volunteers. Everybody does different things. Some people just advocate, some people do more development work, and some people do actual research and mathematical models. So it's a bit of everything. Tor is a network and is a non-profit. We have about 2 million users every day using the Tor network. I said user, not people, because we don't know if those are people. They could be machines. And we have 6,000 relays and about 1,000 bridges. Those are nodes in the Tor network that volunteers run so that you can use it. So what does Tor do? Tor provides privacy to begin with, provides anonymity, provides communication security, provides a traffic analysis resistant communication network. Those are mainly the same things said in different ways and to different people maybe, different set of people that would understand the concept with different words. But the last point, it's the most important point for us, and is Tor provides reachability against censorship. Most of the people that use Tor want to access Facebook because they cannot do it in their own country. So how does it work? Tor provides privacy by distributing trust. You have your traffic routed across a network of nodes run by volunteers, and this is different from the idea of running a VPN, where you only have one single point of failure or one single node where your traffic goes out, and you need to trust the service that you're using. In this case, you don't have to trust anyone. The trust is distributed across the network. So, okay, we have Alice and Bob, because we always have Alice and Bob. So Alice wants to visit Bob. Bob is a website. Alice has a Tor client and obtains a list of nodes from a directory server, picks a path to the Tor networks and reaches bob.com. So the purple lines are encrypted and they run into the Tor network, and the green line is out in the internet. And the encryption protocol on that connection depends on the encryption protocol that Bob is using in this case. So if they're using HTTP, the traffic is in clear. If not, it's encrypted. So it's always important to use secure protocols, even if you're using Tor. So if then Alice wants to visit a different website, like Jane, Alice client will pick a different path, totally different path, and will reach jane.com. So there is no way, in generally speaking, to trace the two connections and understand that Alice is visiting Bob first and Jane later. So this is one concept that we always say is that Tor provides anonymity, and it's more than encryption anonymity, because so if I'm calling a mental health helpline, and the service I'm using doesn't know what I'm saying, but knows that I'm calling this helpline at midnight, they probably know that someone I know or myself has some mental health issues. And this goes for a lot of different things, because encryption doesn't hide the conversation metadata. It can hide the content, but not the information about the conversation. That can already say a lot about the content. Encryption doesn't hide your social graph, who you're talking to. It doesn't hide some metadata from the network. It doesn't hide your location. But anonymity does, and this is what Tor provides. So there is always this question about why Tor provides a browser, and this is because we think that the Tor browser is the way that you can surf the web in a safe way. And this is the easiest way to provide safe use of Tor. And Tor browser is a modified Firefox. There are some things packaged inside. It's Tor, Tor button, Tor launcher, no script, and HTTPS everywhere. And the idea, the properties that you get by using Tor browser is, of course, you use Tor safely, then just running Firefox over Tor. It's a little bit different, but also it's engineered, let's say, to reduce linkability between different activities. So the idea that you visit a website first and then another later, the advertising network on both websites wouldn't be able to recognize you unless, for example, you are logged into Facebook and Google while using Tor. So we also provide these things called onion services to have what we say bidirectional anonymity. So the idea is that you reach a website within the Tor network. The service stays in the Tor network. So if you remember the green line representing an unencrypted connection, that green line doesn't exist anymore. The service stays in the Tor network and can enjoy all the properties provided by the Tor network. So there are some other interesting things about onion services. They can be started from your computer. They are peer-to-peer, they are decentralized. Because they live on the Tor network, they have a smaller attack surface. They provide bidirectional anonymity. And also, the onion service address are public keys. And with version 3 onion service, you can create as many subkeys as you want. So ideally, you can use different keys for different purposes. So more or less, this is how onion service work. Bob is an onion services and picks 3 nodes in the network and builds a circuit to them. These are called introduction points. Then advertise the service to the directory service, which is basically a database, and says, hey, I exist, and send some information to the database. And then there is Alice. And Alice knows that Bob exists. So they ask some information to the database and set up a Tor node that is a rendezvous point. So Alice has learned the introduction point from the database, picks one, and send a message to Bob, telling Bob something like, hey, meet me at the rendezvous point, and also send a one-time secret to Bob. Bob connects to the rendezvous point, they exchange a secret, and they just use a Tor circuit as normally. So between Alice and the rendezvous point, there is a 3-ops Tor circuit, and between Bob and the rendezvous point, there is another 3-ops onion circuit. So it's basically 6 hops of a circuit. So that is the thing. We have these services. How do we use them? The idea is to have a little bit of ecosystem of application and service that live on the Tor network. So the first thing is like, okay, I set up a SSH service from a Docker container from my computer, and I use it because I need to. And okay, I have a container, I have some configuration, and I just start the container, and that's on my computer, and it's accessible through SSH, via Tor, of course. So if you want to set up a SSH server, in reality, you just need to configure the Tor CC file and just change a few lines. You set the in and service directory, the port that you want to expose, and the port of the service that is running on the machine. The Tor CC file is a lot longer, has a lot of configuration options, but it's all for all the different cases that you might use, like running relays and so on. So there is these things, there is Tor SOCKS, and it's bundled into Tor when you install it on your system, and it's like a wrapper application for SOCKS 5. And you can use it for running Tor commands over Tor. So if I want to run curl, I do it over Tor SOCKS, and that's running over Onion. So over Tor, so I can access Onion service, or I can just, if I want to use some APIs privately, I can do it through that. And of course, I can use it also in while I'm programming or scripting or developing something. So if this is a small example with using requests for Python, and I do a get over an Onion services, which is archive.torproject.org, and I could do that through Tor SOCKS, basically using the SOCKS 5 interface that is exposed by Tor. So, but there is more that I can do. So the idea is this thing is decentralized, it's peer-to-peer, I can run it from my computer, and I can do a lot more with it. So there is this sharing application, which is very small, it's called Onion Share, and it's used basically to say you want to send a file to a friend, you start Onion Share on your machine, Onion Share starts an Onion service, you upload a file, and your friend can access that file through the Tor browser without using Dropbox or anything. And when you don't want the file to be available anymore, you just shut it down. And that's it, and it's gone. So the idea is that, what if I want to share a static website to a friend, just for some time? HTML, JavaScript, CSS, images, nothing fancy, but I want to put it online, and I want to host it on my computer just because I'm working on something and I want to share it. So this is basically a hack at the moment. I don't know when it will go into Onion Share, but it shares. It's a GIF, by the way. It shares a folder with a website and all the files, and it makes it available on Tor browser. And so the way it does this is Onion Share is a Flask application, so it basically injects the HTML of the files you want to share when you read it. So this is it started, copy the address, put it there on Tor browser, and yeah. It's loading. But anyway, yeah. So it injects the HTML from the files you want to share into the Flask templates at the moment. This is it's a bit rusty, but it's working. And this is like the support project from Tor, and that's me stopping the casting. So, but there's something more that we can do, right? What if just instead of sharing files and running static website, we can launch any service that we want for our computer. We put in a container, and we have a wrapper application, and we just have it available on the Tor network easily, just because we want to test something or just because we want to use it. And there is these things that I was working on. It's called My Onion, And it basically starts Docker containers with, at the moment, there is only the configuration for running a web service with Nginx and fetching a website. And again, it's very few lines of code that actually do the code and do the work. And I wanted to show this to show that it's not complicated to use this. It's not some obscure technology, and with a few lines, you can already start doing something. And in this case, I just call Docker with this client variable, and I send the containers website. It's just the Docker file, the folder where the Docker files is, and I just launch it, and basically that's it. This is the configuration for the container. It's Debian, and it's pretty basic. Okay, the video doesn't play. That's fine. But if the idea was the same, like with Onion Share, that you have an application, you click a button, and you receive an Onion address, you put it into our browser, and it's available. So this is why it's interesting. Onion services live on the Tor network, provide anonymity to the service provider and the visitors. You can host them from everywhere. You don't need hosting. If you wanted to run a website from your computer, you could. And that's it. They are basically the gateway to having decentralized services that are safe to use. This is the most important thing. And I don't know, for me it's very important because the idea that you can run something so easily from your computer, from your home, and then make it disappear, in a way sets you free to many possibilities of stuff that you can do. And one practical example I have of this is that in some countries, hosting is expensive. So what people do, they set up Onion service on Raspberry Pi, and they have the website for their shop, for example, running from there. And of course, it might not be 100% reliable, but it's still free. You still can do whatever you want with it. So that's it. You can send questions.
You explained that the event service are decentralized, but in the slides where they subscribe to the directory services, the directory services appear like just one node. How is that handled? Is one node or is?
It's one node, but it can. Yes, sorry. The question is that if Onion services are decentralized, how come they advertise to the directory services, which is just one node? So the thing is, on the Tor network, any node can become a directory service for a long time, if it's online for a long time. So you start as a relay, and then if you have good performance of the relay, you get promoted to different roles within the network for a certain amount of time. So while it's true that they advertise to the directory service, any node can be a directory service. There was a question upstairs, actually, before. The same question. Okay, so you're free.
How do you manage load balancing? Is there a possibility to have several nodes that would respond randomly, like round robin?
The question is about load balancing for Onion services, and there is an Onion balancer, but at the moment it doesn't support the function that you would expect for an Onion balancer, like for example to have many Onion balancer. So it can be a bottleneck. But there is this person called Alec Moffat. He works at Facebook and has been working on the Onion service that Facebook use. And he has been working a lot of the Onion balancer and so on. So if you Google Onion balancer and his name, you will find a lot of stuff that he has found working on this. Go ahead.
As a hoster, IPv4 are not that much available. And depending on the protocols, they require one IP per service. So, for instance, SSH is not equal to HTTP, because with HTTP you can do SNI, server name identification. If I use Onion in front of SSH, can I then do kind of SNI for SSH?
I don't know if, sorry, the question is regarding SSH and HTTP and IPv4, and if you can use, how does it change when you use Onion services? But
The problem is I can put many different services behind one IP with HTTP world, but with SSH world I have to run one IP per service.
the IP doesn't matter because it's on the Tor network, and all it matters is the key that is used for the Onion service address. So imagine that you, on the same machine, you could have different services that are Onion services, and they are available for different ports. But also the thing is, you could also change the keys if you want the keys not to be known, for example, and other things. But IP doesn't matter anymore because it's only the key at which is the service address. Yeah.
Different services under the same
I don't think so, actually. Sorry, if you could run different Onion services under the same public key, I think the key is an identifier. So I assume that for each service you have a key. But I wouldn't know if you change something with the ports, maybe you could do.
And you share the same key with two different computers, so that you can provide
I'm not sure. See if you could share the same key with different computers. I'm not sure. You could try to export the key, but every time you create an Onion service, Tor creates a different key. And you can do some key management, but I don't know about fallback. I'm not sure. I think they cannot be active at the same time, basically. So it's like two different addresses. So, but if you want to export it so that you keep the key, yes. Yep.
I wonder, how do you pick entry node?
So the question is, how do you pick entry nodes? And this is the Tor client that does it. So it's basically you receive a list of nodes and you pick randomly among that list. Yeah.
So you have three introductory nodes that you connect, and when you access the core
Say?
whether my three, whether three first nodes that you
So the question is about the node that you use to use the Tor networks. So they are free for the Onion service, you mean? Not for your client. So the idea is in the algorithm to use 3 introduction points and have them use different points. I'm not sure why 3 exactly. In the case of the hops, it's because of there are some models about the idea that you entry from one side, the middle node doesn't know where you're coming from, and the exit node just see the middle node, basically, that kind of thing. So it's in the algorithm, in the Onion routing.
How can we help Tor?
So how can we help Tor? That was the question. You cannot run relays, which are the core of the network, which is the main thing. You can volunteer your time advocating, developing, researching on Tor. You can donate if that's what you want. They give you t-shirts in exchange and other things, or nothing, depends. But mostly it's helping the network, using the browser, be part of it. Thumbs up. Okay.